and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be starting Unit 2, Lesson 1, Fractions and Mixed Numbers. Now, Unit 2 is our unit in Math 6 on fractions. Okay? Now, we're not going to take it all the way back to the beginning with fractions, but I do want to lay the basis in this lesson about what fractions are, what their meanings are, and how they relate to both mixed numbers and division. All right? And then we're going to get into way more with fractions as we move forward in Unit 2. But let's start with just a little discussion before we even go to Exercise 1 about why fractions even exist. So, one of the real sad things about the way that you learn math, and specifically the idea of numbers in math, and this is very understandable, is that you first learn about numbers in terms of counting. I have one thing, I've got two things, three things, 4, 5, etc., right? And that makes all the sense in the world, especially if you've got a situation like this, where you've got 3 pizzas, right? I've got 1, 2, 3, I can count them, right? They're wholes. And that's fine. Until, of course, we have less than one of these things. Until we have a portion of one, or maybe we have somewhere between 1 and 2 of these things. That's when counting breaks down and we get into what's called measurement, right? So the difference between counting and measuring is that counting is all whole numbers. I've got 0, 1, 2, 3, 4, 5, etc. 3 pizzas, correct? But then, of course, what happens when we take that pizza and we cut it up so that we have less than 1 unit, right? And we decide on 1 unit all over the place. We have 1 foot, we have 1 gallon, we have 1 pizza, we have 1 person, right? We decide on a particular unit, but then if we have only a portion of that unit, how do we represent how much it is? This pizza has been cut up into 8 equal sized pieces. Now, you might say, well, we'll just invent a new unit. We'll call it the slice. And we'll just decide that there are always 8 slices in a pizza. That's what we did with feet and inches, right? There are 12 inches in a foot. So we didn't really decide to go with fractional feet. Sometimes we have those in problems, but mostly we'll say, that person is 5 feet, 4 inches tall. We won't say they're 5 1/3 foot tall. Okay, but we still want to be able to represent how much this portion represents in terms of the number 1, right? And so what do? We say, well, we cut this thing up into 8 equal portions, and we have 1 of them. Therefore, somewhere, we have 1/8. And it now allows us to say, if we've decided on this as the unit, whatever this is, 1 candy bar, if I now give a person a smaller amount than that, I can say, well, I cut it up into 5 pieces, and here are 2 of them. So you've got 2/5 of a candy bar, right? I could take 6 of these pieces, and I would have 6/8 of a pizza. And always keep in mind, right, the numerator and the denominator of a fraction are as different can be. The denominator always represents how many equal-sized pieces we cut up 1 unit into, and then the numerator represents how many of those pieces do we have. So if I took a pizza and I cut it up into 100 slices, which would be very small slices, and I gave you 8 of them, you would have 8 1/100ths of a pizza. Again, not that much pizza, but whatever, So let's now use this knowledge, this very basic knowledge about what fractions mean, to start to understand sort of what fractions mean in terms of mixed numbers. All right, let's do exercise 1. Consider the fractions 2/5 and 7/5. In letter A, it says in the diagram of the rectangle below, which has been divided up into 5 equal parts, shade 2/5 of the rectangle. Now again, I just want to be very clear. The idea here is that this entire rectangle represents the number 1. One thing, 1 rectangle. So what I want you to do now is shade in 2/5 of the rectangle. This should be very fast, but pause the video now and go ahead and do that. All right, well, let's shade 2/5 of that rectangle. The idea, of course, is that since I've divided the rectangle up into 5 equal parts, 2/5 of it would just be 2 of those 5 equal parts. Easy enough, right? But what happens when I suddenly have the fraction 7/5, right? Let's take a look at that in letter B. 2 rectangles are shown below, each of which has been divided into 5 equal parts. Shade a fraction that represents 7/5. Then convert this improper fraction into a mixed number. So let's talk about that a little bit before you do the shading and you do all that work. An improper fraction is one where the numerator, right, and that's the number of pieces that we've taken, is larger than the denominator. And that's how many things we've sliced the 1 unit up into, right? Now, it's easy enough, right? We have 1 large rectangle, 2 large rectangles. You pause the video now, shade in 7/5, and then try to use the diagram to convert that into what's called a mixed number. And a mixed number is always a combination of a whole number plus a fractional portion that's less than 1. Pause the video now and go ahead and do that. All right, now again, keep in mind, right, I've got 2 units here, 1, 2. Both of them have been broken up into 5 equal subparts. So this is 1/5, 2/5, 3/5, 4/5, 5/5. I'm just going to write that really quick. Another 5th and another 5th for 2/5. All right, and of course in total, I've just shaded 7/5. But, and this is extremely important for everything that we do in all fraction kind of lessons, 5/5 is just equal to the number 1, right? Because if I cut the number 1 thing, 1 rectangle, 1 pizza, 1 candy bar, 1 gallon, if I cut it up into 5 equal parts and I take all 5 of them, then I've taken the whole 1 unit, the whole 1 rectangle. So this is just 1 and another 2/5. And that is the mixed number, which we're going to write like this, right? Now it's a little tricky because it's kind of like you've got 2 numbers sitting beside each other, the number 1 and the number 2/5. But really what this is this is really 1 plus 2/5, right? We've got a whole 1 plus an additional 2/5, but we write it like this, which can actually be a little bit confusing. Now, based on all of this, let's take a look at letter C. Based on your work from B, change the improper fraction 28/5 into a mixed number. Explain how you arrived at your answer. So I want you to think about this a little bit. I want you to pause the video and really try to figure out what mixed number 28/5 corresponds to. Pause the video now and think about this. All right, well, let's go through it. Now, it's really important to understand that every 5/5 that we have is a whole unit. So like literally, you know, I could have something like this, 5/5, right? That's equal to 1. Another 5/5, that's equal to 1, right? So, you know, I'd have 5/5 plus another 5/5, that would be 10/5. Plus another 5/5, that would be 15, plus another 5, that would be 20/5, plus another 5, that would be 25/5, and then I'd have 3/5 left, right? And again, make sure you understand, right? 5/5, that's just 1. Another 5/5, that's 10/5, but then that would be 2, 3, 4, 5, and 3/5, right? Each one of these, right, is just a set of 5/5, and we have 5 of those. Sorry, that could be a little confusing, plus an extra 3/5, right? And again, the key here really is the fact that I can figure out how many of these basic units of 1 I have by kind of thinking about how many 5/5 I have. That could be a little confusing. So we're going to work on that more in the next exercise. All right, exercise 2. We want to convert each of the following improper fractions into mixed numbers. Show how you arrived at your answer. All right, so again, let's think about this for a minute before we just kind of blindly go with some kind of method that, oh, this is what you do and here's your answer, okay? 15/4. All right, think about this for a minute, right? 15/4, right? Every 4/4 is going to be equal to the number 1, right? So you've got 4/4 plus 4/4 plus 4/4. Now just for a minute, pause. 4 plus 4 is 8, plus another 4 is 12, right? And then we'd have another 3/4. So all of this would be 12/4 plus 3/4. Now, what's 12/4? Well, 12/4 is equal to 3. So this is 3 3/4. Now, what's the key here? You know, how can we do this without having to kind of write all of this out? Well, notice what 12 is it's a multiple of 4. And that's key, right? I mean, we want to find out the largest multiple of that denominator that's still less than the numerator, 12/4. And what did 12/4 become? It became the number 3 because 4 divides into 12 3 times. Let's take a look at that on letter B for a second. Right? 33/7. Think about the largest multiple of 7, because I have 7/7, 7/7, 7/7, etc. The largest multiple of 7 that's still less than 33. Think about that just for a minute. It's 28, right? You know, it's like 7, 14, 21, 28, 35, etc. So we could think about this as 28/7 plus an extra 5/7. Right? 28/7 plus an extra 5/7. And 28/7 is 4 groupings of 7/7. And I can figure that out just by doing 28 divided by 7. Right? So this just becomes 4 and 5/7. Now, you might already start to get an inkling that this has something to do with division, right? Because 33 divided by 7 would be equal to 4, and then there would be a remainder of 5. And that's really kind of the quick and easy way of converting improper fractions, where the numerator is greater than the denominator, into a mixed number, right? So let's try one of those kind of together. Here I have 57/10, right? Well, how many times does 10 go into 57? It goes in 5 times, right? For a total of 50, but then we're left with 7 left over. Right? So if I literally thought about it as 57 divided by 10, I'd have 5 with a remainder of 7. So this would be 50/10 plus 7/10. 50/10 would be 5, and then we'd have 7/10 left over. Try the last one on your own and see what you get. All right, well, over here, you know, maybe on the side I think, all right, what's 61 divided by 8? Well, that's 7, which would give me 56, subtract, and I have a remainder of 5. And again, the idea here is that I can think of 61/8 as 56/8 plus 7/8. That 56/8, that's equal to, plus 5/8. That 56/8 is 7, and then we have that extra 5/8 tacked on. All right? Converting an improper fraction into a mixed number by literally figuring out how many sets of these 7/7, 10/10, 4/4, etc. We do that by division, and then the remainder, what's left over, just goes over the denominator for that fractional portion that's in between the two whole numbers. All right, let's keep working. Let's do some more review. Exercise number 3, a nice applied problem with fractions. Let's take a look. Kai is filling up an inflatable pool with water. He adds water in the amounts of 2 5/8 gallons, 3 and 7/8 gallons, and 4 and 3/8 gallons. How many total gallons of water did Kai add? Express your answer as a mixed number. All right, now you may remember some things in 5th grade or maybe even 4th grade about how to change a mixed number back into an improper fraction. But let's not worry about that for right now. Let's literally write out the sum, right? Okay, so, he's got 2 and 5/8 plus 3 and 7/8 plus 4 and 3/8. Now, at its very basic essence, what I don't want you to forget is that 2 and 5/8 is 2 plus 5/8. 3 and 7/8 is 3 plus 7/8. 4 and 3/8 is literally 4 plus 3/8. So due to how nice addition is, I can first say, well, let me just add 2, 3, and 4, right? So I'm going to kind of group it like this. 2 plus 3 plus 4. And then I'll add all these 8s together. Right? So this is simple enough, right? And it kind of makes sense. I mean, if I was estimating this, I might first say, well, I've got the 2 gallons, the 3 gallons, and the 4 gallons. And then let me add up all those fractions of a gallon. So here I just have 2 and 3 is 5. 5 and 4 is 9. So I've got all of that. Plus, what do we have here? Well, I've got 5/8 plus 7/8. That is 12/8. Just as if I had 5 oranges plus 7 oranges, I'd have 12 oranges. So 5/8 plus 7/8 is 12/8. Plus another 3 is 15/8. But 15/8 all by itself is an improper fraction, right? And what is it? Well, 15/8, I'm going to just make sure I don't lose that 9. Well, that's 8/8 plus 7/8. And 8/8 is just equal to 1. So I have 9 plus 1 plus 7/8, and that's 10 and 7/8. Right? 8/8 is 1, 9/9 is 1, 10/10 is 1, 3/3 is 1, 2/2 is 1, 4/4 is 1. Right? We need to be able to kind of recognize this fundamental idea about fractions. Let's keep going and now see if we can go in that opposite direction where we take a mixed number and we try to turn it back into an improper fraction, simply a fraction with a single denominator. So let's take a look. Converting a mixed number to an improper fraction, exercise number 4. Consider the mixed number 3 and 3/4. Divide the 3 rectangles below into fourths. How many fourths are there? All right, so pause the video just for a moment. Take each one of these 3 rectangles, divide it into fourths, and just count up how many fourths there are. It should be pretty simple. Go for it. Okay, nice key to dividing something into fourths. Divide it into half, and then divide each half into half. So in other words, if I take this first rectangle and I divide it in half, and I divide each one of those halves in half, right? Right? Then of course, what I have is I have 12 fourths. Right? So 3 rectangles, 3, is equal to 12 fourths. So letter B says, write 3 and 3/4 as a sum, and then use your answer from A to write it as an improper fraction. Why don't you go ahead and do that? What would this mixed number, 3 and 3/4, be as an improper fraction? All right, well, again, it's this simple, right? 3 and 3/4 is the same as 3 plus 3/4. But the number 3 is just 12 fourths. So plus 3/4 gives us 15 fourths. Right? So we can move from this mixed number form back to that improper form as long as we can take the whole number, 3, and figure out what it represents in terms of that denominator. So the number 3 represents 12/4 because each 1 unit is 4/4. If I had the number 3 and I wanted it to be in terms of sevenths, it would be 21/7 because there would be 7/7 in each one of those ones. So let's get a little bit more work on this in the next exercise. All right, there's going to be many times in this course where we're going to want to take a mixed number and for a variety of reasons turn it into an improper fraction. So let's take a look at letter A together. Right, the number 5 1/2 is literally just 5 plus the fraction 1/2. But if I want to know what the number 5 is in terms of halves, all I have to do is multiply it by the denominator, 2. So 5 is the same as 10 halves. So 10 halves plus 1/2 is 11 halves, right? And again, I want you to just think about it. If I had 5 candy bars, right, and I cut them up so that I had half of candy bars, I would have 10 of those halves. If I cut them up into 3 parts each, I'd have 15 of those thirds. If I cut them up into 8 parts each, I'd have 40 of those eighths. So it's really easy to figure out what kind of fraction that whole number represents with that denominator by just taking that denominator and multiplying it by that whole number. Let's do another one together in letter B. In letter B, I have 7 3/4. So that's the same as 7 plus 3/4. And again, I want to know, well, how many fourths does the number 7 represent? Well, 4 times 7 is 28. So 7 represents 28 fourths. Plus the 3/4 gives me 31 fourths as the mixed number. All right, I'd like you to get a little bit of practice with this on letter C and letter D. Pause the video now and take as much time as you need. All right, let's do it. I'm going to keep doing the same procedure because I want to hammer home what each one of these things really represents. 11 2/3 is literally the number 11 plus the fraction 2/3. I take a look at that denominator and I say, all right, how many thirds does 11 represent? It represents 33 thirds. So if I add 33 thirds to 2/3, I get 35 thirds. Let's do letter D together. Again, 3 7/8 is 3 plus 7/8. If I want the number 3 in terms of eighths, that's going to be 3 times 8. That's going to be 24 eighths. Plus 7/8 gives me 31 eighths. All right. I will kind of never forget, for some reason, the trick that my math teacher showed me back when I was in maybe 5th or 6th grade, which was simply taking the denominator of that fraction, multiplying it by that whole number, that gives me 28, and then adding the numerator of that fraction, giving me 31 fourths. Right? And again, the idea here is that we're always thinking about how many fourths 7 represents, how many halves 5 represents, how many thirds 11 represents, etc. All right, let's wrap this up. So today, what we did is we reviewed the basic notion of a fraction. This idea of taking 1 unit, right, whatever that one is, a gallon, a foot, a yard, a candy bar, a pizza, taking that 1 unit and cutting it up into a certain number of equal-sized pieces and then taking a certain number of those pieces, right? That gives us the idea of a fraction. It leads to the idea of fractions that kind of look like the number 1, like 5/5, 7/7, 10/10, right? And then using those types of ideas to convert between improper fractions, where the numerator is larger than the denominator, and mixed numbers. We're going to be using these skills as we move forward, obviously, in this unit, and we'll see them more in the next lesson that we do. For now, I'd like to thank you for joining me for another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.